There would be rules. So rules of each topics, you can say each chapter, uh, could be different, could be separate, you can say. So here I am trying to tell you that we need to understand rules. We need to know rules of each chapter. Whatever we are going to study. So before studying, we need to study. We need to know rules of that chapter. Then we will be able to play with that chapter. Here, our this is not a chapter of this lecture, but as I told you, a little tiny information I would like to share with you about this. Number system. Here, what is number system? Means a system of numbers. For example, numbers. What is the meaning of one number? Numbers. 1, 2, 3, 4, 5. But here, we have a lot of numbers. We have categories of number. So then tell us. Okay, I tell you what. Randomly, I am telling number system. In the category of number system, we have a rational number, irrational number. I am telling you randomly. I am telling you randomly. So number system, rational number, irrational number, real numbers, integer. Somebody says integer, somebody says integers. Okay. So here pronunciation of integer word could be different, but spelling of integer would be same. Okay. So integer numbers, then first of all natural number, then whole numbers, then integers numbers, then rational numbers, then irrational numbers, then real numbers, and towards this number are more numbers. But in the context of 8th class, we study till the rational number. We study rational number deeply. Whereas in 9th class, we study rational number, but total numbers, whole number, natural number, integer numbers, rational numbers, and irrational number. You can say irrational number. In 8th class, rational number, and in 9th class, irrational number, and in 10th class, a real number, and then 11th, complex. This is a series of numbers. That's why we say number system. So in a number system, these are numbers that I told you. Okay. So did you understand? Just whatever I told you. Yeah, it's a time to understand each numbers that I told you. That is that will be compulsory to now just for today lecture. So okay, do you know this is what this is what a line. What name of this line is what? A ray line. Ray line. Okay, I am not going in details about this line. Lines also we will discuss in separate lecture. Okay. So our focus is on number system. So I am trying to tell you is that this is what with the help of this we will understand name of each numbers. So we start numbers from 0. Okay. And you can say if you familiar with the coordinates, then you know already what this is x-axis. This is not a y-axis. As well as this is a horizontal line. This is a horizontal line. This is not a vertical line. So vertical line will be like this, and horizontal line is like this. And x-axis, this is the x-axis. So y-axis would be like this. Okay. So here, this is x-axis. If you are familiar with the coordinate, if you are familiar coordinate, then you know what is this axis, x-axis. If you don't know, I am telling you this is x-axis. If horizontal, there is a horizontal line, then horizontal line will be considered as x-axis in the context of coordinate. And with the help of coordinate, we try to understand each numbers. It will be very easy to understand with the help of this x-axis. Okay. Why I am telling you? This side we write this side. This you can say this is left and this is right side. So this right side we apply. We write numbers of addition. Of addition. 1, 2, 3, 4, 5, 6, 7. So here these numbers are with what add. Here add is hidden with each this number. Add hint, add operation, you can say add operation is hidden with each of this numbers. So remember, add hint will be hidden with numbers, but subtract will not be hidden with numbers. Subtract will be visual. Subtract will be visual. So I was trying to tell you this right side will be add and this left side will be would be what subtract. Subtract. Okay. Left, which means subtract. Right, adding. Okay. So we start from 0, but here. From here to here is how much? 1. If we are measuring in meter, then we would say 1 meter. So measure of from here to till here is how much? 1 meter. From here to here, 1 meter. Again 1 meter. From here to here, again 1 meter. What if I ask you from here to till here, how much? 2 meter, because 1, 2 meter. Already you are familiar. Now let's understand numbers. If we are starting from 0, if we are starting from 0 and number this is an end of infinite. This arrow is a hint of infinite. Okay. So it is saying, it is telling us that this will be going on. This will keep going on. Okay. Here 7, 9, infinite till the infinite. So from 0 to the infinite numbers will be considered as whole number. Will be considered as whole number. All numbers. Whole number. Okay. It is the time to understand natural number. If we are starting from 1 to the infinite, then this will be considered as a natural number. Natural number. Okay. Whereas I am not taking these numbers, because if we take these numbers, then this addition, add numbers. These are add numbers and subtract numbers. So both will be considered as what? Integers. Integer number. Okay, integer. What about rational number? So remember, If we are taking so natural number is also known as a counting number because we have what we can count, then we can say natural number. Zero which cannot be counted. Zero tells us there is nothing. So zero is not a counting number because zero is not telling us any number of something. Okay, so one it is telling us yeah there is a object which is one. Okay, so remember natural number is also considered as a counting number because of natural number is a counting number. That's why. Okay. So integer will take subtract also and as well as add. Okay. Now rational. So rational says P by Q. Here you would say rule. Rational says between this is a number. Between these are numbers. Between these are numbers. How much? It can be infinite. So between two numbers are numbers which is rational numbers. Rational number. For example, 4 minus 4. Let's say this is a 4, this is a 3. Otherwise, we have a minus 4. Okay, control by. So here, 4 by 3. 1 by 4. 1 by 3, 2 by 3, 3 by 3. Three by 1 by 4, 1 by 2 by 4, 3 by 4, like this. So rational number describes that rational number will be in form of P by Q. P is a number and Q is also number. So numbers are in ratios, otherwise P by Q. Then it is a number which is name of this is rational number. Okay. So if number is numerator by denominator, it is a rational numbers. Clear? But remember, Q denominator should not be 0. This is rule. This is a warning. Denominator, which is number, but the number of denominator should not be 0. This is a condition. This is a warning from a rational number. And rational number is defined as P by Q, in which Q should not be 0. P is 0, then it doesn't matter. But Q is 0, then it will matter. This will, if for instance, 4 by 0. So this is infinite. This is known as infinite, not defined. It can't be defined. So these numbers, this is a number which is said what not defined, infinite, not defined. Okay, infinite or not defined. So this is not our topic, but remember, it is compulsory to understand why cannot we write in the place of denominator 0. Why can't we write? Because of if we write in place of a denominator 0 number, then we will not have a number. We will not have a number. Instead of a number, we will have infinite. We will have infinite. So it is not telling us what? It is not telling us a number. Okay, that's why. This is rational numbers. Irrational number. Yeah, irrational. Irrational. What do you understand by irrational number? It explains number which can't be irrational number is a number which can't be uh, expressed as p by q, as p by q. Am I right? P by q. Yeah, p by q. What are those numbers? What are those numbers? Root 3, root 5 and root 6, root 7. So these are numbers which is known as irrational number, because it can't be. It is said that irrational number can be written as p by q. That's why. Can you write root 3 in the form of a p by q? How? As well as irrational number is also known as non-ternate numbers. Non-terminating numbers. Terminating numbers. Non-terminating numbers. Irrational number is also known as non-terminating numbers. Meaning of this is what? Terminating number, which number is ending. But whereas non-terminating number, which means number is not end. Number is not at end. Okay. When we write this number, irrational number, in decimal, then we won't have a complete number. For example, this is let's say 1 point something. So this is end of a non-terminating. Whereas when we write like this, it is a terminating number, because this is end here, but this is not end. Okay. I hope I tried to teach you about the number system. In this, we understood about whole number, natural number, and integer number, and then irrational number, as well as non-terminating numbers, and infinite. What was this? So it was just a little information. Now our main topic is what? Quadrilateral. Just have a look. Then I would like to move on, which is our main chapter, main discussion. Now let's talk about quadrilateral. Quadrilateral. It is what shape? It is a shape. Understanding quadrilateral. Understanding quadrilateral. So let's start from beginning. Uh, what do you understand about curve? Can you explain? What do you understand about curve? How would you describe this word? How would you describe? If you don't have any idea, then okay, there is no problem. If you know, then what is your style to describe word, to describe it? What will be your perspective? What will be your words? Okay, let me explain. This is curve. When we speak, when we say curve word, then our mind says curve, this like this, like this. So here we are not thinking straight line. We are not thinking straight line. When we said curve, then our mind is indicating us like this, like this, like this. Curve, like this, like this. This is curve. So here word, if word, a word what straight, then we think what this is it. But here we are looking, we are observing what curve. So yeah. So here we first when we start, then we have a point. When we to make a curve, first of all we will have a point. So first point will be also known as initial point, and then second, which is last point, where we end. Okay. So here there would be 2 points. First, which is the starting point, and second, which is ending point. To draw a curve. So without lifting, once you start to draw a curve, so without lifting the marker or a pen, whichever you have taken to draw a curve. So when you start, so first we observe what a point. Then without lifting, where we end, we will have second point, which is last point. This is, but can we say this is curve? In this case, we have also 2 points, and we followed same rule as we understood in this context. So can we say this is a curve? No. This is a straight. We already are familiar. That this is a straight. So why can't we say this is what curve? Yeah. There. Here we understand that this is straight because this line is in straight. So curve would be like this. So here you can say what a curve would not be straight. That's it. Curve would not be straight. Here you can say. Okay, this is what. Yeah, we applied same points as we were understanding here. But this is a straight line we already know. Okay. Now, open. Open curve. Okay. Curve. What is the meaning of open curve? Here, word is open, which means something is open. So something is what? Curve is open. Curve is open. So curve is open. Curve is open is the meaning of open curve. But how can we describe it by drawing? It is very simple. If our curve, our two curves, three curves, our curve is our curves, our curve is not intersecting to each other. How? Example of intersecting curve is like this. This is curve. But here, can you observe where is the intersecting view? Where is the intersecting view in this diagram? Where is? Here. This is intersecting. This is intersecting. Those who don't know what is the meaning of intersecting, I am telling you intersecting, which means in the context of mathematics, in the context of curve line, I am telling you. If two lines intersecting, if two lines are intersecting to each other, like this, cutting. If two lines are cutting to each other, so where we are looking cutting view of two lines is a intersecting part of that diagram. Similar here, this is one and this is a second. So here this is two, which is one is let's say this is a straight. Otherwise, two curve. We have only one curve. So here this curve is intersecting to this curve. That's all. So this is intersecting and this is intersecting to intersect. How many are intersecting in curve? It doesn't matter, but in their explanation of open curve should not be intersecting part of a curve. Then we will be able to say it is what diagram is curve. Curve is open curve. When there is a no intersecting view there. Clear? So what is the example of open curve? So this is the example of open curve. This is example of open curve because here we are not observing intersecting view. That's why. Clear? And here you can see this is open area. As well as this is open area. But here warning is what? There should not be view of intersecting. Then we would say what? Open curve. So warning is what? There should not be intersecting view. In this case, in this diagram, we are not observing intersecting view. That's why we can say this is an example. This is an example of open curve. Now, can it be an example of open curve? Of course, yes. This is what? This is an example of open curve. But this is not an example of open curve. Clear? Closed. 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 No. First we understood what are curve, open curve. Now there is a closed. It is very important to understand meaning of word in which there is a chapter. So meaning of main word will be compulsory to understand. Then we will be able to understand of a chapter. To understand a chapter. So what is the meaning of a closed curve? It is very simple. It is very simple. But what? is the same. Closed curve should not be open curve. Closed curve should not be open curve. Closed curve is also curve, but curve should not be open curve. If a curve is open curve, then it is not a explanation of a closed curve. So closed curve should be closed. Closed curve should not be open. So, what is the diagram? Just I draw what a diagram of a closed curve. But here you are, it's like a complicated. It is looking complicated. But this is what we are trying to understand about closed curve. So here, can you observe open area of this curve? No, open area. No, there is no open area. That's why we don't call it as open curve. Okay. So can we say this is a closed curve? Yeah, because this curve is closed. That's why. Okay. That's why. Now here you would say what? So in the context of a closed curve, should be intersecting view? Of course. Yes. Yes. Of course. Yes. Now, simple closed curve. Just to be understood what closed curve will have what intersecting view. Closed curve would have intersecting view, but simple closed curve should not have intersecting view. That's why here we are observing we have what simple word. So closed curve should be simple, not complicated. This was complicated. This is complicated. And here we are looking intersecting view. But in the case of simple closed curve, so first of all, closed curve is a curve, but closed curve should be simple, not complicated. When we say simple, then when we say simple, then we don't observe intersecting view in the diagram of a simple closed curve. It is a description of a simple closed curve. Okay. I hope you have understood. There is no doubt. That's it. So what's it? If you wanted to understand, if you wanted to know what is the difference? What's the difference between closed curve and simple closed curve? Yeah, let me explain. Here, difference is nothing but something. If we have two words which is intersect, which is connection between them, then we will have something little difference between them. When there is a connection between them, then what is the difference between this? Difference is closed curve would have complicated curve. Closed curve would have a complicated curve as well as intersecting view. But simple closed curve would not have complicated curve as well as intersecting view and as well as what it would be simple curve. This was the difference. So an example of a simple closed curve is what we can say. This is here we are not observing intersecting view. Okay. Here we are not able to observe intersecting view in the diagram of a simple closed curve. That's why we call it simple closed curve. Now, what else? Intersecting the next point was what? Curve, simple closed curve should not be complicated. This is very simple. This is not complicated. So complicated can be said when there is or whatever intersecting you. Then we will have complicated closed curve. Complicated closed curve. Oh, it's time to understand about the polygon. Polygon. We are moving. We are taking next step towards this chapter. First, we have understood about curve lines. Curve lines. What do you understand by polygon word? Polygon word. It could be a new word for you. For you. It could be a new word for you. So those who know meaning of this, can you explain? No. Here we will observe what closed closed word. We will observe. Now let's see. When it comes on a polygon word, on a polygon discussion, then it explains that to make a polygon, to create a polygon, to draw a polygon, we should have three or more. Three or more. I was thinking, then I said what three or more, because of we if we have one or two line segment, then still we can't draw, we can't create or make a diagram of a polygon when we have one or two line segments. Why? Okay. Hold on. I said you to draw a polygon. It is a shape. Remember, it is a shape. So to draw a polygon, we should have what at least three line segments. And to draw different polygon, we should have what three or more polygons. Oh, no, more line segments. And now line segments should be closed. Then we will have polygon. Do you understand? No? Okay. Let me clarify. Okay. I described that to draw a polygon, we should not have one or two lines. Instead of one line, two lines, we should have three lines, at least three lines. And to draw different polygon, we should have three or more line segments. First, this is line segment. Do you understand? Are you able to understand what is line segment? In the case of line segment, to understand the definition of line segment, it has this line. This line has two ends point, two end points. Whereas this is a second. Two end points we have, isn't it? We have Now, two endpoints, which is what ending points. So this is a, you can say this is a definition of making a line segment. Okay, this is one line segment. Now I am going to take second line segment. Still, we can't say this is what a polygon, because of this is not a closed. This is not closed. No, second. When it will come, or when we will have a three line segment, then I will would make a polygon. Okay. So I, this is what, this is the second line segment, isn't it? This is line segment second. Now, can we say this is a polygon shape? No, because this is open. This is open. This is not closed. So to make it closed, we will apply next one more line segment. So to make it what closed, we are applying line segment here. Now we have three line segments. We have line segments. Okay. Now as well as we have what closed, uh, we have drawn line segments by observing what closed. This is closed curve. This is closed shape. It is what shape? Now we have a shape. Now we have shape. So if line segments is closed, then we have a polygon. So here you are already familiar. This is a triangle. This is a triangle. Yeah, you are right. This is a triangle. Now it depends on you. If you want to name it, then you can say like this. Okay. And I think you noticed, you observe what first polygon is what triangle. Then second would be what quadrilateral. Then third pentagon. Okay. So if we have a three line segment, then we will be able to make a triangle. If we have a four line segment, so then we can create a quadrilateral polygon. If we have four line segments, I wanted to ask you, what can you draw a quadrilateral polygon with the help of two line segments? Of course no. That to draw a quadrilateral polygon, we should have what a boy should have what four line segment. Then he will be able to draw a quadrilateral. So I think you are crystal clear. To draw a triangle, a person would have what three lines segments. To draw a quadrilateral, a person would have four line segments, and four line segments would be closed. Three line segments would be closed. Then we will have triangle. Then we will have quadrilateral. Yeah, this is quadrilateral. Okay. This is polygon. Remember, polygon is a closed, as well as polygon has what? Polygon has line segments. Polygon can have curve because circle is a polygon or not? Of course, yes. Of course, yes. Pentagon. To create pentagon. 1, 2, 3, 4, 5. This is a pentagon. Pentagon polygon. To create to draw a hexagon. 1, 2, 3, 4, 5, 6. This is hexagon. Poly. Similar septagon, octagon, nonagon. Like this we create. There is a pentagon. So pentagon polygon has 5 line segments, whereas hexagon polygon have has how much line segments? How much? I think hexagon 6. Now here you can observe what angles. You can observe angles. To define more about polygon word, we can say what polygon can have angles. Here, this is angle. This is angle. So we have 3 line segments. Then of course we would have what 3 angles. If we have a 4 line segment, then we would have 4 angles. Then we would have 4 angles. Okay. Diagonal. In the case of a triangle polygon, we won't have a clear diagonal. We won't have a clear diagonal. You can see diagonal. Vertex. Are you familiar to vertex? Vertex, which means two adjacent made at a point. Here, this is vertex. This is vertex. This is vertex. So these are adjacent, which is not opposite to each other. Okay. To draw a diagonal, we start from a vertex to the opposite vertex. So here there is no vertex. That's so I said you triangle polygon would not have a clear diagonal, whereas quadrilateral polygon it has what clear diagonal, and to draw or diagonal in a polygon we start from vertex to the opposite vertex. So here this is vertex. Adjacent, do you know where is adjacent in this quadrilateral polygon? This is adjacent, this is adjacent, this is adjacent, this is adjacent, this is adjacent. Yeah. Let's go. So this is a vertex. We are drawing diagram. So from here to the opposite vertex, we'll draw a line like this. Okay, this is diagonal. And here two diagonals are intersecting to each other, which is at O. Clear? I hope you have understood something. In this case, like this, like this, like this, like this, like this. We have a star. Okay, like this we draw diagonals. And our topic is what quadrilateral polygon. Just have a look. We have understood to draw a polygon, definition of a polygon, angles in polygon, line segments, vertex, adjacent, diagonal. Yeah. Curve, open curve, closed curve, simple closed curve. Now it's a time to move on. Shall I move on? Now, a regular polygon and irregular polygon. I am telling you, it is very simple. It is not complicated to understand about polygon, regular polygon and irregular polygon. Irregular polygon. Can you tell me? Is it a regular? Is it regular polygon? Is it irregular polygon? Okay. This will not be possible until I describe regular polygon, irregular polygon. Regular polygon, irregular polygon. Before we understand the difference between them, let's understand meaning of each this words. Irregular polygon. If first of all, a regular polygon is already polygon. Polygon have what? Polygon has what? A regular polygon has sides. Yeah, already. But all sides of a polygon are equals. Are equals. Are equals. Are equals. As well as angles. Measure of angles is equal, then we can say that polygon is regular polygon. So all sides should be equal. So each sides of a polygon is equal to each other, as well as measure of angles of that polygon is equal. Each angles of that polygon is equal, then we can say that polygon is regular polygon. But in the case of irregular polygon, it is just opposite. It is just opposite. Regular polygon explains that all sides would not be equal to each other. One side would be 5 centimeter, third side would be 7 centimeter, fifth side would be 3 centimeter, like this. So it is telling us what this is irregular polygon, as well as so if you are observing that angles, so there would not be possible angle would be equal, each angle would be equal of unequal sides of each unequal sides. They would not possible. If there is a possible, then here we can say what each sides measure of each sides is not equal, and measure of each angles of this same polygon is the same. Then we can say this is irregular because of each sides of that polygon is not equal. That's why this is the reason. Did you understand? This is the reason. So measure of each sides of a polygon is not equal, as well as measure of each angles of that polygon is not equal is a meaning of irregular polygon. That's it. So remember, the regular polygon which have each sides is equal, as well as measure of each angles is equal, is considered, is known as regular polygon. Okay. Whereas we have a polygon which is a regular polygon. How to identify, how to investigate that polygon, this polygon is regular, this polygon is irregular? How to identify? What's the point to identify polygon or regular polygon or non-regular polygon, regular polygon, irregular polygon? Okay. So first of all, I told you what to identify a regular polygon. So each sides of a polygon would be equal to each other, as well as each angles, measure of each angles of the same polygon would be equal to each other. Would be equal to each other. This is how we identify a regular polygon. Now, irregular polygon. To identify irregular polygon, we have to observe what each sides of that polygon is equal or not. If yes, then we now we need to observe angles, measure of angles. If measure of angles of each angles of that polygon is not equal, then we can say this that polygon is irregular. This is how we identify, we investigate a regular polygon or irregular polygon. Okay, I hope you understand. If you want to see written in a written form meaning of a regular polygon, then okay, I have what a regular polygon. Yeah, examples. For instance, for instance, mm, what? A square. Yeah, a square. A square polygon. What else? Quadrilateral. Quadrilateral. No. A square polygon. What else? Uh, Forward, sir. I will tell you. No need. It was just an example. No need. Irregular. Irregular polygon. Okay. For instance, in this are examples which are rectangle, then quadrilateral, quadrilateral, quadrilateral. Let us see. As of now, let us see. Have a look. This is a definition in written form of irregular polygon. Irregular polygon.